Hey guys, my name is Alex, and today we're going to be talking about manufacturing for small businesses and what I've learned from it so far. So the three main things that I've done my research on are 3D printing, injection molding, and casting. And you can tell which one I chose. Um, but yeah, so the easiest one it seems to me to get into is 3D printing. That's what I got started with. And it's because you can get a printer for like $250 to like $450. Mine was on the upper end, but that's because I really wanted exactly like the set number of features. Um, but yeah, and then every time you print something, you it'll probably take you like 4 to 24 hours. Um, so you can't print too fast. You can't make things that fast unless you've got multiple printers, and it depends how much money you've got to start off with. And then every roll of filament costs about $25, um, and that'll last you maybe like 4 days of straight printing. So you can get a reasonable amount out of it, but it's going to cost you like several dollars in plastic per print that's like of actual quality. And the nice thing is, most of 3D printing is all about settings. Like the difference between a newbie to an expert is mostly just how you set it up. Because you can get prints that have like lines all over them, they look gross, they're misaligned, um, and they really look like someone squirted plastic out of like an icing tube and didn't really know what they were doing. No hate on cake bakers, they do an awesome job, but us average people don't. And then you have the option of like making something that's so clean that you can't even tell where the layers are the printer printed. It just looks like one completely smooth structure, and it's strong as something that is just injection molded. um, and so to give you some background on how these three technologies work, and then I'll go into injection molding and casting. um, 3D printing is literally like you have, I mean, you can't really see it right here, but there's like a little nozzle that moves around, and it's printing like a 2D shape of something. And then it goes up just a little bit, prints another 2D shape, goes up just a little bit, prints another 2D shape. And so now you've got all of these shapes, and you can like make a vase per se by starting with like a small circle and slightly larger circle, slightly larger circle, and you keep going up until it gets large enough and wide enough at the top to put like a flower in. um, and the way it actually works is that it's feeding solid plastic through a very hot small piece of metal, which then forces it out as a liquid, and then right after it comes out, it blows a fan on it and it cools the plastic so it solidifies. So it's just liquid for a very small amount of time as it's actually being laid into this pattern. Um, Injection molding, on the other hand, is you have a die, which is like, you can imagine like the object you want to make. It is that shape removed from a giant piece of metal. Um, and then you will shoot liquefied plastic into it and allow it to harden, and then release it, and like open the mold up, open the die up. It'll fall out, and then you can close it and do the next one. And the third one is casting. So casting, you've probably seen things for this, like even at your local craft store, like Michael's or Joann's or something. Um, and you can literally just like take a shape. It's usually silicone, um, and fill it with a liquid like resin, and then just let it harden. But there's a lot of nuances in between these because the cost of materials, the quality of the materials, the quality of the finished products, that's going to be game changing. Um, and so your options here, like now with injection molding, is like that is a ridiculously high startup cost. First of all, you have to know that it's going to sell whatever you're making. You have to know that you're going to get return on investment, and you have to know like that the design that you're putting forward is the one you want to stick with, because making changes to a die is very difficult, and some of these dies cost as much as a house, so if not more, right? And that, so if you want an example of what like really good injection molding looks like, look at the Lego company. Like, they have pieces that no matter how much they've altered their system, still fit. The pieces that they've updated today are still compatible with their pieces from the 70s. Like, they are ridiculously on top of it, and their tolerances are really good. Like, there's things that you can't view with the naked eye, so you don't see like little bits of plastic coming off the ends and stuff, and that's the result of a very high quality mold. But like I said, here you have a machine that costs like as much as a house, and unless you know you're going to be making a lot of something, it's not worth it, because it might save you costs in the long run by having very, very cheap plastic that you can buy in bulk. But for things that are like for a small business, you probably won't want it, because you're not going to have that many customers up front, and you don't want to bankrupt yourself just to get behind an idea. And that was kind of my thought process with this, is I don't want to do anything that's going to be so expensive that if it fails, I can't try a different project. And I think that's a pretty good philosophy, because you don't want to go bankrupt. We live in a world that is financially difficult to survive in. Don't make it harder on yourself. Um, and then you've got this other option, which is casting. Oh, and so the cool thing with injection molding, though, is yeah, the plastic's a lot cheaper. Um, but unlike this, you can't actually make like super, super complex parts. You can make complex surfaces, but the issue is it's going to be completely filled with plastic unless you do something like blow molding. You need a mechanical engineer if you're going to do that. This is something that a hobbyist can do. And you can make just the exterior of the shape, so you're saving a lot of plastic there. Casting, though, you can do this with cement. You'll probably see a lot of this stuff mostly on Etsy. You can do it with cement, carbon fiber, like liquid resins, polyurethane. You can do it with molten plastics. It can be anything. Problem is, it takes a really long time to harden, and it's another one of those things that's like hobbyists can make it really easily with a few resources. You can go and get, like, say you want to make like a little tray for your desk. They have molds of that at Michael's. It'll cost you probably $15. Pour some resin in, and you call it a day. But that works well, except that you can't make things quickly. Like if you're doing it with resin, especially, it's gonna take possibly a couple days to harden. So unless you've got a ton of these and you've got a ton of time to carefully pour it and make sure you don't like burn your skin off with some of these epoxies, you kind of have to like weigh the risks here. But that is the cheapest one to get started off with if you're looking for something small. But you have this other issue of like, hey, I want to make something more complex than what they just sell with pre-made molds. Well, now you've got an issue again. You need to get a new mold. And then this is where it gets interesting, because you can now hybridize these technologies. You can take any one of these combinations and add them together. But before I go into that, I want to talk really quickly about outsourcing, because this is interesting. This is what a lot of companies do nowadays. You don't need to have the know-how to necessarily pull it off yourself. You don't need to have the factory space either, because there's companies like the one I keep seeing is Xometry, but there's a bunch of different ones. And essentially you can be like, hey, I want you to make this part for me and let them handle it. But you need high margins for this, because you're paying shipping costs, you're paying the cost of them designing new machinery for your parts. But the nice thing is they're experts in it usually, so they know how to compensate for the difficulty of this. If you want something injection molded, they can do it. And you don't have to go through the hassle of hiring a team of mechanical engineers and manufacturing engineers to figure out where and how you can actually go about this. So it's a good option, but you need to know you're going to make money. And that's true with most of these things. So, hybridizing. This is interesting because it is taking these much more complex technologies and putting them in the hands of your average person, or someone who's done a lot of research who's an average person. Because now you can take something like, I guess it's like ballistic steel. I don't remember what the material is called, but we'll call it epoxy resin. Silicone. Sorry, silicone. So you can take a part, 3D print it. Which, by the way, you can 3D print flexible materials. You can 3D print non-stick materials. They're very hard to print with. Don't recommend it unless you really know what the heck you're doing. I'm included on the list of people that doesn't totally know what they're doing, so I'm not going to screw up my printer with that. But I screwed it up in many other ways. This fixable tangents. Anyways, so the thing here is you want to be able, you can print your part and then put it like in whatever, a box or something, pour the molten silicone over it, and then when it solidifies, you have a mold that now you can take your old part out and you can keep filling this with resin, you can fill it with liquid plastic, whatever, and it will now harden in that shape. issue here when you're comparing like casting to injection molding is an injection mold may be good for a couple 100,000, if not a couple million uses, even more if they're better designed. But a silicone mold will probably only be good for like 20 to 50 if it's a small part, 10 or less if it's a big part. Um, so you really have to know what you're getting into. And regardless, I think the most important thing here is do your research. Like, know when I was going into this, I was like, okay, even though I'm printing on 3D printer, there are standard plastics for this stuff. The question is, what plastic do I use? How much do I cool it at? I have altered literally every setting in my slicer, which is how you convert a file to something that the printer can read. So it is like it does require you to actually sit down with what you're doing. And realistically, if you want to run a company, even just a minorly successful one, like mine's only made $500 in the last 12 months pretty much, but I'm still learning how to make it larger. And this was kind of the trial run. I didn't want to lose a lot of money setting this up. Uh, but yeah, you got to make sure it's profitable, and you've got to make sure you're doing your research, right? And something that some business professors have told me, and even my engineering ones told me, is like, if you're going to start one of these projects, you need to be able to answer or know how to find the answer to every question that you can come up with about this topic. So who's going to make it? How much is it going to cost? How much energy is it going to take? Where am I going to make it? How am I going to store all of it once it's made? How am I going to get it to my customers? What is the most optimal way to do this? And I'm doing this without investors behind me, which is a choice that I've made on my own. I have gone to investors before, but this is something that you have to consider for yourself too, because you are giving a share of your company, or yeah, a portion of your company to these people, possibly for the rest of the time, depending on how you write your agreements. Talking to lawyers also good, but in my experience, I don't have that kind of money. And you probably don't either if you're just starting. Anyway, so this is mostly about manufacturing, but there's a lot of like little tangents and stuff that you do need to be thinking about as you go. Hybridization is continuing from where we left off, right? You've got these silicone molds that now you can make something in. And these are good for medium scale stuff because now it's like I can print something once, and instead of it taking 24 hours to print every time, right? And I only have one printer and those are expensive. I can make multiple silicone molds, and then I can keep, like, even if it takes 24 hours for the mold to solidify whatever's in it, I can have 15, 30, 100 of those. And yeah, it's going to take me time to pour all of these, but I don't need to buy new machines. And the silicone is relatively inexpensive by comparison. So there's a lot to be gained from that. And then it gets more interesting because I started seeing people create at-home injection molding machines. And that's really where I want to go. And in manufacturing, you have the idea of low quantity batches and high quantity batches. So am I making 10 of something or am I making 10 million of something? And that completely changes what kind of machine you should be using to make it. And there's a whole bunch of other things to consider, like surface finish. How smooth do you want it? How reflective do you want it? How much do you want it to stick to something else? Is it going to be multiple materials? Is it going to be multiple colors? These are questions to ask, and you shouldn't be overwhelmed by them. But eventually you have to consider the answers to most of these questions. You will never have all the answers, but you should be pretty confident in what you're doing if you're going to ask someone else to put money in it. And that is true for both an investor and a customer. Uh, so yeah, so right in the middle of those two is medium quantity manufacturing or mid quantity manufacturing. That's where it gets interesting because this is where you have a bunch of emerging technologies, the kind of stuff where people have made like something about the size of this cabinetry that can injection mold. And it can only mold one thing at a time, but you've just taken a whole factory's worth of equipment and space and people out of the process because you don't need to make a million of these. But if you are doing something that requires injection molding, this is the better option because you don't need all this equipment, but it can give you the surface finishes that you want. It can be cheaper plastic wise. It can be cheaper possibly energy wise. So a good option. I took it in a different direction though, because I don't necessarily have the tools to make an injection molding machine. A lot of the ones that I've seen people making are not available commercially yet. They're not available to the public. Um, so I'm trying to make my own solution, which is a 3D printing factory. But it works a little bit different from other ones that I've seen because those require either someone to come on and hands-on, like remove parts, set it up, clean up the print bed and everything, um, or it requires I can't remember, but it takes more maintenance essentially, right? I want this to be completely hands off. Like I want to set up a factory where my time is spent doing research and development, and the factory is running itself, and all I have to do is fix machines but not maintain them. So that means I can just put, like, I know approximately how fast I'm going to go through all the filament I have. I can place new order for filament every so many days, put them all in, just set them to run, and then I can run this while I'm sleeping. I can queue prints, and that to me is game changing, because so this is something that I've been working on developing for a year now. Because as I was developing my first product, it was just toothbrush holders. I went through and I'm like, dang, the bigger issue here is not the issue I was solving with toothbrush holders, which is that you get gunk in the bottom of yours if you don't have a drain in it, but it's the fact that if you're making something as a small business owner, which most people are, and a lot of them are taking gambles with their finances, you need something that doesn't cost that much money, that can run itself, so you get your time back and can actually put into something valuable. Um, and especially in the American economy, we're all trying to buy our time back, so it's pretty important that you have things working for you that don't take away your time or someone else's. Because if you hire someone, you're just passing the problem down the stream without actually increasing efficiency. And we need jobs, but we don't need to torture people, which is what a lot of these low wage kind of jobs turn into. Um, so the way I'm doing that is basically adding tons of parts. You can kind of see here, but I've got like a thing here that when the printer is done printing, the RAM, which is this part with the googly eyes, will run into the object after it's cooled, and it'll pop it off, and then it goes onto this part which is flexible. And you can't see it right now, but there's a box below it that it just falls into. And so I was working on developing that. I wrote like additional code. I've changed a lot of the settings in the slicer to make it so that it can actually like I can control the printer head with my own code instead of just it's going to make this part and it's going to use all the pre-made settings. I wanted to get in there. And so so what I'm designing is essentially a full kit. It's got like the electronics that you can't totally see over here, but it's got like the case, the wires, and everything that allows you to remotely control your printer and like not need to actually go hands on with it. It means that you can now upload files directly from your computer. In my case, it also means you can upload them from your phone, and you'll get emails every time it's done printing. One of the things that I've developed is a software that reads my emails to check when I get orders from Etsy, and it will put those in a queue. Well, it sends them to an Excel spreadsheet. Then the spreadsheet is read, puts it in a queue for the printer to read automatically. So it literally goes from someone orders, it goes through my email directly into the printer. And then when it's done printing, it sends me an email. That email can be read and checked off the list of completed parts. And at the end of the day, all I need to do is box these things up and send them to the post office. And then there's the boxing side. And this one's interesting because these machines are also incredibly expensive, kind of like injection molds, but instead of having really, really high quality parts, they just have a lot of parts. And so it still makes it expensive. Um, but I was like, dang, I don't want to have a machine for packaging, for folding the boxes, opening them, for putting tape on them. Like I want to kind of have this comprehensive process. So my idea was pretty much like a 3D printing vending machine. And that is definitely still on its way to happening because boxing is almost harder than this whole 3D printing automation thing. But I designed a handful of parts that like can hold the box open, can push like a tip into the fold of the box to pop it open. I figured out how to like automate printing the what do you call it? The labels, the shipping labels, as soon as my print gets read. And so part of this video is for me to tell you about the technologies that exist, and then about the way I'm trying to solve this problem, because it's either a solution that you can use and develop it yourself, or it's something that you can use once I've released these products. But ultimately, there's a lot of labor saving to be had. You can optimize every single part of this process, because I mean, why would you not? Would you rather be working on like a factory floor every day, having to move these parts out of the machine itself, or would you rather be designing a new product, sending something out for your customers, for your fans to go and enjoy. And for me, the answer is do things that people will actually want to buy and not be stuck behind the scenes. It's rewarding to be behind the scenes, but if you're not moving something forward, then you get stuck there. And so that's really what I'm after here is making this a process that you can actually use. So that'll wrap it up for now. As we're going forward, I'll show you, like I said before, more and more parts of this process because I want it to be accessible and I want it to be useful. And of course, go down in the comment section, let me know what kind of questions you have. I'd be happy to answer them, and so would the rest of the members of the community. See you guys in the next one.